All right. Good afternoon, everybody. Good to meet you again at virtual meeting. At least I can feel that you are there. Yesterday you had midterm before I start the class. Let me just tell you, I just want to receive one or two messages. Mr. Qasim, can we see our solutions? Actually, this is online midterm online exam. Okay, if you're really interested, actually, when you're doing the questions, you need to take the screenshot of every picture, and after that you need to analyze. Okay, and after that, if you think that your score must be different, then you can send email to my you can email me so that I should receive official email. All right, and I will see if there is no mistake. That means that you have to retake the midterm. If there's a mistake, then I will correct this. Okay, why am I doing this? Otherwise, just actually checking every student's paper, I mean, that's one by one, it takes a lot of time. Why? As you know, actually, I prepared a bunch of questions, and uh, questions are selected randomly, and you need to answer only 20 questions out of those questions, maybe 40, 30, whatever it is. Okay, so every student's, I mean, the question order is different, questions are different, and one by one I cannot. But if you're 100% sure that your score should be different at that time, let me know. Okay, so you need to send me official letter, then we can actually discuss this together. Okay, guys, let's continue. uh, As you know, we were talking about applications of derivatives, and last week we started with extreme values of functions, and what we did in 4.1. Actually, we just learned that actually we had two important theorem there. Number one, if you're given any continuous function over the closed interval, then it must have global maximum, and it must have global minimum. That's one important theorem that we are going to use this here. And number two is, if we are given a continuous function over a closed interval, right? And the function assumes its global maximum or minimum either at endpoints or at interior points. And also, actually, we had one definition, critical point. Critical point is defined as where the derivative of the function is zero or it does not exist. Simply, geometry interpretation means that at a point, if you draw a tangent line to the curve, if the tangent line is vertical line or if it is horizontal line, those points are called critical points. Okay, those things are that you actually keep in mind. Today we will talk about one important theorem, that is the mean value theorem. In the second session, after we actually have 10-minute break, we will have another short session, and we will talk about monotonic functions and the first derivative test. In our tomorrow's meeting, we will talk about concavity and curve sketching, and also if you have time, we will start applied optimization. Okay, next week, maybe on Wednesday, we will talk about Newton's method and antiderivatives. So in this way, we will finish this chapter, and most probably you will have another quiz either next Friday or after, Monday. Okay, Monday you will, let's say it's Monday, you will have quiz from chapter 4. When is it? It will be, um, okay, July. All right, this will be March 22. Okay, March 22, you will have quiz from this chapter, March 22. That is quiz 2 dates, okay, from chapter 4. Okay, guys, now let's start this chapter. Before we move to our main theorem, that is the mean value theorem, actually we are going to prove this Rolle's theorem. Okay, so we know that constant functions have zero derivatives, but could there be a more complicated function whose derivative is always zero? Anyway, if two functions have identical derivatives over an interval, how are the functions related? We answer these and other questions in this chapter by applying the mean value theorem. First, we introduce a special case known as Rolle's theorem, which is used to prove the mean value theorem. Actually, if you have noticed, as you practice more and more, as you learn more and more about math, you will see that actually everything is somehow interconnected with each other. Okay, and sometimes we just start with very simple definition, and after using this simple definition we obtain some theorems, and using this using these simple theorems actually we try to solve more complicated questions. Okay, so let's start with the Rolle's theorem. Rolle's theorem says that if we are given continuous function over a closed interval, okay, suppose that y equals f of x is continuous at every point of the closed interval AB. So if you pay attention here, our interval is closed interval AB. And differentiable at every point of its interior. At interior point, it is differential function. And f of a is equal to f of b. Then there is at least one number c in AB at which f prime of 0 is equal to 0. Okay, so what is here? What's going on here? If we are given three facts, actually these three facts, what are these? Number one is we are given a function which is continuous in a closed interval. And number two is it's differentiable at every interior point, which means that it is, uh, what is it? Differentiable at interior point. And also we have one more condition. Here we have, what is it? F of A is equal to F of B. So here we have three conditions, right? Number one, number two, number three. The first one is it is continuous over the closed interval. Number two is it is differentiable. Number three is F of A is equal to F of B. It means that the values of the function at endpoints, they are equal to each other. If it is so, now this theorem guarantees that here there exists at least one number in C. Okay, there may be more, maybe infinitely many. Okay, not infinitely many. Let's say it's a lot, but in AB, but at least there's one C such that where the derivative of the function there is equal to 0. That means that there's one point if you draw a tangent line there, actually is equal to 0. Why is this so? Proof is not so complicated, and we are just going to use theorem 1 to prove this. According to theorem 1, if you remember again, if the first part, if the function is continuous, right? Because the first condition says that it must be continuous. What does it mean? If it is continuous, then the function has global maximum and global minimum. Now from here, the second one is we know that if the function is continuous and it has global maximum and minimum, where does it occur? Okay, if actually we answer this question, where does it occur? Last time we have already seen this. Either it occurs at endpoints, right, or at interior points. And if it is at interior point, that means that that point is a critical point. So what is the critical point? Critical point is where the derivative of the function is equal to 0 or it does not exist. But in the theorem, actually, it says that it is differentiable. So the critical point is where the derivative of the function is equal to 0. We just rule out the condition that it does not exist. Okay. So if the global maximum or global minimum occurs at, what is it? At interior point, now we are done. We have that point is where f prime of c is equal to 0. And how about if it happens or if it occurs at endpoints? That means that f of a is equal to f of b, and we are saying that either f of a is maximum value, f of b is minimum value. That means that maximum value is equal to minimum value, which means that all the values of the function they are equal, which means that it is a constant function. So at the time it's constant function, we have a lot of points, right, where its derivative is equal to 0 because constant function's derivative is always 0. Now, what happens actually if one of these conditions fails actually? For example, let's say it is continuous everywhere. It is continuous everywhere, but only at one point. As see here, at one endpoint, it's not, what is it? Continuous. So at the time, we cannot use this theorem, okay, because the first condition is not satisfied here, or it does not hold here. So actually, it must be continuous over the closed interval. But here in the first case, it's not continuous at A. And that's why we don't have any point where the derivative of the function is 0. Or simply, you cannot draw any horizontal tangent to the curve over the interval AB. How about the second one? At interior point, at only one point, the function is not continuous, right? At x sub 0, it is not continuous. But here, f of a is equal to f of b. It's not continuous. And it's direct also, which means that it's also not differentiable at this point. Again, at that time, this Rolle's theorem does not work for this kind of functions. Okay, it must be continuous over the closed interval. It must be differentiable over the interval AB, closed or not. It's not important for differentiability. Actually, the third one is f of A is equal to f of B. Then we can use that theorem. And the third one is, as you see here, it is continuous everywhere, right? From over the interval AB in graph C, but only at one point, at this point, x sub 0, the function is not differentiable. Why? Because you cannot draw any tangent here. We have a lot of different tangents. Maybe if you just, anyway, it's not differentiable there. It's a kind of cusp, right? So that's why also we cannot say that there is C in AB where f prime of C is equal to 0. It does not exist. So all these three conditions must be satisfied. Then we can actually have that Rolle's theorem. Okay, consider the polynomial function. Okay, for example, how do we apply Rolle's theorem to this function? Right. So now from here, if you solve this question, for example, f of x, let's just find the zeros of this function. Take, let's say, 1 over 3 x out. So here we have 1 over 3. I have x out. What do we have here? X squared minus 9, or which is equal to 1 over 3 x, and here we have x minus 3 and x plus 3, right? Which means that at 0, f of 0 is equal to f of 3, because also at 3 is equal to 0, and also here at negative 3, right, it is equal to 0. And that means if I just draw our number line, as in the picture, and here at negative 3, it is 0. At 0, it is 0. At 3, it is 0, right? And also, actually, it is a polynomial function, which means that it is a continuous function. And also, at the same time, it's differentiable at every point, right? So now using Rolle's theorem, since here, the first condition, let me just continue from here. Number one, since f of negative 3 is equal to f of 0, right? And it is continuous over the interval from negative 3 to 0, and also differentiable over this interval. So actually, this Rolle's theorem then guarantees that there exists some number. I don't know what is it. Maybe later you'll find how learn how to find this. There is it at this one point on, what is this? Negative 3 and 0, where f prime of c is equal to 0. Okay, let's see, we are talking about this point, right? So this point is, let me just write here, C1. That's the first point, right? And also, if you just consider the second actual interval from, what is it, 0 to 3, right? From 0 to 3. Here, 0 to 3, f of 0 is equal to f of 3, right? And also, it is continuous and differential everywhere. And also, actually, this Rolle's theorem guarantees that there exists at least one point, at least, over the interval from 0 to 3, where f prime of C2 is equal to 0. Okay. So simply over this interval from negative 3 to 0, there's one turning point, and also from 0 to 3, there's one turning point. There, actually, the function has turning points without finding this. Okay. Now, if we know that, then we can look for that value. Another question, show that the equation x cubed plus 3x plus 1 equals 0 has exactly one real solution. Okay, it means that I need to show that it cannot have two solutions, which means that it has, number one, actually two steps. Number one, I have to show that it has solutions, and number two, it has only and only one solution. So we will do this in two steps. Number one, existence. Okay, number one, existence. Now from here, I'm just going to use that's, what is it, intermediate value theorem. So here, suppose that our function is f of x is equal to x cubed plus 3x plus 1. Okay, let's say at negative 1. F negative 1 is equal to negative 1, negative 3 plus 1, which is equal to negative 3. right? And how about at 0, f0, that's equal to 0 plus 0, and here we have 1, that's equal to 1, right? So that means that actually, as you remember, intermediate value theorem says that since f negative 1, right, the value of the function at negative 1 is negative 3 and 0 at 1. And also we know that 0 lies between negative 3 and 1. Then by intermediate value theorem, there exists at least one value, right, over the interval negative 3 and negative 1. Sorry, not negative 1, it is 1, where f of x sub 0 is equal to 0. Okay, which means that we have a root, maybe more roots. Okay, so now on the other hand, uniqueness, and now I'm going to show that it is unique. It's only one. Okay, so what is f prime of x? F prime of x is equal to 3x squared and plus 3, right? So actually, if it is so, right, if we have another roots, let's say, suppose that I have another roots, and this one is some value, let's say this x sub 0, where is equal to 0, and suppose that I have another value, all right, here. And on the left or on the right, actually it doesn't matter. Suppose that we have another root here, where I'm expecting that f of x1 is equal to 0, right? So now from here, as you see, our function is a polynomial function. It is continuous and it is differentiable at every point on the number line, right? And also here now I have condition here. Let me change the color here. So here also we have another condition here. F of x sub 0 is equal to f of x1 is equal to 0. If it is so, then there must exist, by Rolle's theorem, right, some point over the interval x sub 0 and x1, right, where f of c should, f of prime of c should be equal to 0. But what is f prime of c? Actually, f prime of c is equal to, now we have already differentiated, that's equal to 3 times c squared plus 3, right? And when is equal to 0? Never. Even it is greater than or equal to 3, right? It's never equal to 0, which means that such point does not exist, which means that actually we don't have such x1. We don't have such point, right? If we have, actually it must satisfy this condition. We should be able to use this Rolle's theorem. Now, actually, we can get the conclusion that there is only one root of this equation. It doesn't have more than one root. Also, that's actually one important thing in math, okay? Okay, it has a solution, but another question is, how many solutions does it have? How many roots does it have? So to answer this question, we can use this theorem, just one application. Okay, now let's move to our main theorem here. That's a mean value theorem that we're going to use this very frequently from now on, okay? Especially in integral, we will use this a lot. If the mean value theorem says that, suppose here f of x is continuous on a closed interval AB and differentiable on the interval's interior AB. If we have two conditions, then there is at least one point C in AB at which f prime of C is equal to f of B minus f of A over B minus A. Right? Actually, on the left-hand side, what is it? We know the f prime of c. It is the slope of the function or tangent to the curve at point C, right? So simply in the graph, you can see that the red line, this theorem is saying that if the function is differentiable over the interval AB, and also if it is continuous, then there is at least one C. Okay, now if you just draw a straight line that is passes through the capital A and capital B, I can draw another straight line that is tangent to the curve, which is parallel to this straight line. We actually call this, what is it? What is it? Second line. We call this second line. That's parallel to this second line. Okay. So now so we will see this application. Why is it so? To actually prove this, now I'm going to write the equation of this yellow line. Okay, since actually this yellow line, it is passes through point A and point B, right? And coordinates of point A, it is A and f of A. And coordinates of B, it is B and f of B, right? So if we are given what is it, 2 points, and also its slope, how do you write the equation of that line? So let's say that actually equation is g of x, right? The equation of the yellow line passes through these 2 points. What is it? Is equal to the slope, which is f of b minus f of a over b minus a, right? And here we have x minus a plus f of, what is it? When is a is equal to b, right? So that is g of x. What is it? F of b minus f of x minus a. So it should be minus, it should be f of a, right? Because if I take this one, g of a. All right. You just write here. If you're given any 2 points, it is passing through this point. It is a, x1 and y1. And this one is b. It is x2, y2. What is the equation of this line? The equation of this line is y2, actually not y2, y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. Actually, this y2 minus y1 over x2 minus x1 is just a slope. Now from here, what is y? Y is equal to y1, right? And plus, here we have y2 minus y1 over x2 minus x1. Take this x minus x1 to the right-hand side. I have here x minus x1. Okay, so from here, if our equation is g of x, right, y1, what is y1? F of a, so that is f of a, actually f of a, g of a, they are equal, right? And plus, here we have f of b minus f of, just write from here, g of x is equal to f of a plus, here we have f of b minus f of a over b minus a, and here we have x minus a. Okay, so now anyway, just using this one, I'm going to form new equation. Okay, what is the difference of this blue line and this yellow line? Let me just denote our function as actually the difference, this one, okay, this one as h function. So then I will have this function, this h of x is equal to our f function, f of x minus g function, g of x, which is equal to f of x. What is g function? Minus, here we have f of a, plus it is minus, here we have f of b minus f of a over b minus a. Now here we have x minus a. Okay. So now I have just actually formed new function. That function is equal to this, and it satisfies all the conditions in Rolle's theorem, right? Because it says over AB, if you look at the function, actually just difference, it is continuous function because f is continuous function, g is continuous function, also the difference is continuous. And also both functions are differentiable. That means that also the difference is differentiable. And if we just check this, what is f of h of a? H of a, here we have f of a minus f of a is equal to 0, x minus a minus a is equal to 0, that's equal to 0. And how about h of b? H of b here, f of b, and here we have b minus a, b minus b, b minus they cancel each other. F of a minus plus is f of a, anyway, that's equal to 0, which means that h of a is equal to h of b, right? So this h function is continuous and it is differentiable there. And also it has equal values at endpoints. Now, if you apply the Rolle's theorem, then what do we get from it? How can I use Rolle's theorem for this? Then there must exist some c in the interval a, b, where h prime of c is equal to 0. So what is h prime of c? From here, that's equal to, on the right-hand side, f prime of c, and the f of h is constant number. If you differentiate, is equal to 0. And here, this thing is just a coefficient. X minus a's derivative is equal to just 1. So here we have minus f of b minus f of a over b minus a is equal to 0. Now, if I just take it to the right-hand side, we will get this mean value theorem. Okay. All right. One example, a physical interpretation. So consider the function f of x equals x cubed over the interval 1, 4. Okay, over the interval 1, 4. What is 1? That is somewhere here, right? And the 4 is somewhere here. Okay. So now, if you actually, what is it? F at 1 is equal to 1, at 4 is equal to 64, right? And that is x cubed. It is continuous function and also it is differentiable. That means that then there exists some c in the interval. What is it? That is interval 1 and 4, where f prime of c is equal to 64 minus 1 over 4 minus 1, which is equal to 63 over 6, equal to 21. Okay. So that means that physical interpretation here is if this one is time, okay, and t is time, and this s is the distance. All right. So between the time interval from 1 to 4, right, from 1 to 4, let's say you traveled, for example, let's say the travel distance is at 4, that's equal to, actually this 1, okay. Let me just change this because here it is 1, 4. Okay, anyway, doesn't matter. So if I just draw some function, okay, and let's say that is the graph of the function, right? And here it is 1, and here it is 4. And let's say it is time. And this one is distance, okay? The first one, actually, let's say it is 10 kilometers. And after 3 hours, let's say this one is 330 kilometers, okay? So over this interval, right, you travel how much? Actually, in 3 minutes, you traveled let's say this 340. Okay, so in 3 minutes you traveled how much? Actually, you covered a distance of 330 kilometers. Okay, so now if you find the average speed, for example, how do you find the average speed? Average speed is 340, right, minus 10 distance traveled over time elapsed, or elapsed time. The elapsed time is 3, which is equal to 330 over 3, 110 kilometers per hour, right? So what does it mean? It means that during this time, from the first hour to the fourth hour, right, during this time, there is a point, right, there's a point where actually your speed is at some point here, let's, I don't know what time is it, okay, t is equal to t0, where your speed, right, what is speed? Actually, it is the slope of the function, right, this v of t, t sub 0, that is f s prime of sub 0, that's equal to 110 kilometers per hour. Okay. So that means that suppose that, for example, at 1 o'clock, you left Phnom Penh, okay, and your initial, let's say, distance, let's say 10 kilometers from Wat Phnom Penh, if you're calculating this, and you're 10 kilometers away from Wat Phnom, and after that, at 4 o'clock, actually, you arrived Siem Reap, okay, and during these 3 hours, actually, you traveled 330 kilometers, okay. So when you arrive, if the police asks, okay, what time did you leave? At 1 o'clock, and you just started counting the distance at 10 kilometers, maybe you just arrange your what is the distance like this, okay, and ask, did you actually exceed the speed limits? Okay, let's say the speed limit is 100 kilometers per hour. So if you say no, let's say the police, they can prove that, okay, here it's 3 hours, right, and your average speed is 110 kilometers, which means that there is a point between this 1 and 4 where your speed actually was 110 kilometers per hour. That's the one application of this thing. Okay, we have two things. We are running out of time. Okay, we have 7 minutes. So another thing is mathematical consequences. If f prime of x is equal to 0 at each point x of an open interval AB, uh, then f of x is equal to c for all values AB, where c is a constant function. What does it mean? Simply, if the derivative of the function is 0, then the function must be a constant function. The second corollary, it says that if the derivatives of two functions are equal, that means that they only differ by a constant number. So that means that if f prime of x is equal to g prime of x, then f prime of x must be equal to g prime of x plus some constant number, nothing else. Only the difference must be a constant number. There are two results that we get from those mean value theorem. Find the function f of x, whose derivative is cosine of x plus 2 and whose graph passes through pi over 2 minus 6, right? So it says that here, derivative f prime of x, that's equal to cosine of x plus 2. And whose graph passes through this? That means that f of pi over 2, that's equal to minus 6, right? So now from here using, how can we actually answer this question? Since f prime of x is equal to cosine of x, right? And uh, what is it? Just from here, this f of x must be equal to minus sine of x, not minus sine of x, just only sine of x, because what function derivative is cosine of x? It is sine of x. And what function derivative is 2? That is 2x. And also since actually here we need to have some constancy, right? Because it's f of x and g of x, right? And the derivatives are the same, so their difference is only c. And also we know that it passes through the point, so that means that f of pi over 2, which is sine of pi over 2 plus 2 times pi over 2 plus c, it should be equal to plus c, it should be equal to minus 6. Sine of pi over 2 is equal to 1, and this one is pi. So what is c? It is minus 7 minus pi. So dot dot dot, our original function, then it is, what is it? Sine of x plus 2 times of x minus 7 minus pi. And the last example, given that the velocity of the body is,
Sir,
yes.
about that, the last question is like we doing integral
Yeah,
from
actually
the,
we will do integral, but here we are just using that actually since this f of x, right? And also here we need to have c here, so that its derivative is equal to 0. But at the end of
okay,
this,
okay.
chapter, actually, we will give a special name. Okay, we call this indefinite integral. But now I'm not going to use this, okay? Because at the end of this chapter, we start using that notation, that indefinite integral. Okay.
Okay, sir, okay.
So right now we have no idea about integral. That's why we should not use integral here. The last example, given that the velocity of the body is given by this and the initial position of the body is this, right? And find the body's position at time t. So to find, actually to answer this question, we need to find the position function. And also we know that since velocity is given here, that is 32t minus 2, that actual position function must be, what is it? 16t squared, because 16t squared prime is equal to 32t, and minus, here we have 2t and some constant c, because constant function derivative is equal to 0. And since also it's given at 0.5, which means that 16 times 1 over 2 squared, 1 over 4, minus 2 times 1 over 2 plus 6 is equal to 4. Now from this equation, we can determine the value of c. So c is equal to 4 minus 4 plus 1, that's equal to 1. So our position function is, what is it? It is 16t squared minus 2t plus 1. And a question is, find the body's position at time t. That is the body's position at time t. Okay, there is no knowledge in science like pondering and thought, and there is no prosperity and advancement like knowledge and science. Guys, now let's have some break. Okay, 10-minute break. After that, we will continue. We'll talk about one more thing, and after that, we will finish today's class. Okay,
Sir,
any questions? Yes.
can you go back to the previous example, which show the equation has one real solution?
Okay. This one,
Yeah.
example 5.
No, example, the first one, they show the some equation that has one real solution.
You mean this one?
Yeah, that one. So
Yes.
how can you know that you need to put f minus 1 and f of 0?
Say again.
So how can you know that you put f of 1 and f of 0?
You mean f of minus one, or are you talking about
Yeah,
this
yeah,
thing?
yeah, that one. So
No, no, no. Actually, last time, if you remember the intermediate value theorem, right? So I'm just checking two numbers so that it gives me different signs of two numbers where they opposite signs are opposite or different. Because I know that between these two numbers we have zero, right? And looking at the question, how can I actually know that? Because if I substitute negative one, you can put any number actually. And just to make sure that when you calculate one value, let's say, uh, I'm just actually, I want this function to have positive value and another value where the value of the function is negative, right? It can be any value. It can be negative one, negative two, negative three, anything. Just to make sure that one value gives us positive value, one value gives us negative value. But simply, just actually negative one comes to my mind if you actually calculate the value of the function negative 1 is equal to negative 3, right? F of 0 is 1. Between negative 3 and 1, we have 0. And after that, according to the theorem, there must be one value where the value of the function is 0. Okay? Guys, I will finish because a few seconds left. If you have questions, next session you can ask. We can discuss again, okay, now, because it's going to end soon. Okay? After 10 minutes, we will have another session. See you soon.